Good afternoon, friends. Now we are continuity equation in Cartesian coordinate system of module number 2 in fluid mechanics. So continuity equation in Cartesian coordinate system. So here we considered a fluid element here. The fluid element will through this the fluid will enter into this fluid element through the face AB CD in x direction. The fluid element is having the length dx, width dy and thickness dz in the direction x, y and z. Let u is the velocity in x direction, v velocity in y and w in z direction respectively. So u, v and w are the velocity components in x, y and z directions. So now mass of the fluid entering the phase ABCD per second. So it is now the flow rate is given as the product of density into a discharge. So rho into A into V. So where A is area of this phase ABCD through which the fluid enters this fluid element. So velocity in x direction. So that is given as U, and area of the face ABCD. So it is having the area, so that is dy here. So the width and height, so that is dz. So area of this face ABCD is now dy into dz. Velocity is now u. So A into V. So rho into A into V. So this is mass of the fluid entering the phase ABCD. Now mass of the fluid leaving the phase, that is in the opposite phase, that is EFGH. Mass of the fluid leaving the phase EFGH. So that is, so rho u dy dz. So there is a gain in the mass. So rho u dy dz plus we have del by del x of rho u dy dz into dx. So that is in x direction. So now we have gain in the mass in x direction. So it is the difference of mass through the face ABCD minus mass through the face EFGH. So taking the difference of this quantity and this quantity, so this rho u dy dz will get cancels with rho u dy dz. So we have minus of this plus, so we are having minus. So del by del x of rho u dy dz into dx. So this is the gain of mass in x direction. So del by del x of rho u dx dy dz. Now similarly the net gain of mass in y direction. So we have minus del by del y of, so now velocity in y direction, instead of u will have v in the equation. So it is rho into v and the volume of the component, so that is fluid element is dx dy dz. So in place of x we have y and in place of u we have v. So that is the net gain of mass in y direction. Similarly in z direction we have minus of, instead of y we have z and instead of v we have w. So del by del z of rho w into dx dy dz. So taking the summation of gain of masses in all the three directions x, y and z, we have del by del x of rho u del x del y del z. So taking all the three components here. So dx, dy, dz is common in all the three terms. So taken outside. So inside the brackets we have del by del x of rho u, del by del y of rho v, del by del z of rho w. So minus is also common. It is taken outside the brackets. So this is the net gain of masses considering all the three perpendicular directions. We know that from the conservation of mass that the mass is neither created nor destroyed in the fluid element. So we take that the net increase of mass per unit time in the fluid element is equal to increase of fluid mass in the element. So mass of the fluid in the element. So that is we have the equation rho density is equal to mass by volume. So I can write mass as density into volume. So density is rho, volume of the fluid element is dx, dy, dz. So this is mass of the fluid element. So rate of increase of mass per unit time. So with respect to t time, we are taking the partial derivative del by del t of rho into dx, dy, dz. So rate of increase of mass of fluid is equal to net gain in the mass of the fluid. So we have one equation here. The other equation is net gain of masses. So this is equated to rate of increase of mass, fluid mass of the element with respect to time. So cancelling dx, dy, dz on both sides we have, and taking minus also the other side. So we have here del rho by del t. So taking all these three terms this side. So minus becomes plus here, and this side 0 is left. So del rho by del t plus del by del x of rho u plus del by del y of rho v plus del by del z of rho w is equal to 0. This is continuity equation in its general form. Now for steady flow, we consider that there is no change in density with respect to time. So del rho by del t is equal to 0. So here considering del rho by del t as 0, we have left with this. So del by del x of rho u plus del by del y of rho v plus del by del z of rho w is equal to 0. If the fluid is incompressible, so here density is constant, and steady flow, there is no change in density with respect to time, so that is also equal to 0. So if rho is made constant, so taking rho outside and taking the other side, it becomes 0. So finally left with rho or del u by del x plus del v by del y plus del w by del z is equal to 0. This is the continuity equation in Cartesian coordinate system.